Welcome to another fantastic episode of Mr. Chow Time, my dear algebra class. Today, we're looking at lesson 5, descriptive modeling and accuracy. This lesson is about using expressions and equations in real life situations. So let's take a look. Our first vocabulary word is metric, which is a rule for assigning a number to some characteristic or attribute. This is a pretty bad definition. So let's take a look at it a little bit closer. So when someone is making a decision about how to classify something that they have numbers for, then that is a metric. For example, how was it ever decided that 90 to 100% would be an A grade? Or that 80, you know where I'm going with this, to 89 would be a B? Or that, if we're using 1 to 8, that 7/8 was the highest achievement. Well, these are metrics. It's some sort of a rule for assigning a number to some characteristic or attribute. So you get a number from some kind of a quantitative thing that you do, and you get out of it some qualitative thing. Debt to income ratio, this is a little bit more straightforward. The debt to income ratio is a metric. So we're going to get a number, and it's going to determine if someone is good enough for something. So it's going to determine if someone qualifies for a loan. This is the metric. You get it by calculating how much a person owes divided by how much a person earns. So let's say I buy a house and I have to take a loan out to buy this house, and I borrow $1 million. And how much I make, I borrow $1 million, but it's how much you owe per month. So let's say I take out a loan for $1 million, and the bank wants me to pay back, some easy number, $10,000 a month. And let's say that I make $100,000 a month. Then this ratio would be 1/10. Here's a number, right? Well, what does this number mean? Well, for every bank, it would be different. But let's say that a bank says that that if your debt to income ratio is less than, 0.15, then we'll give you a loan. Then this would be the metric. Accuracy refers to how close a measured value comes to the actual or desired value. As I'm sure you have learned in science or just from experience in life, measurements are never completely true, right? Like if this is a foot and you measure the foot with a ruler and you come up with 27 centimeters, well, your foot is clearly not 27 centimeters, it's 27 point something. And even if you measured it down to the closest, half millimeter, that still wouldn't be exactly the right answer, right? That's not exactly the truth. And so accuracy refers to how close you can get to the actual real number with a tool. because remember, you're using a tool to make a measurement. So how accurate that tool is determines your accuracy. Let's take a look at an example of metrics and debt to income ratio. So this guy, Ryan, he's applying for a home loan. His monthly expenses are $1,165. His monthly income is $3,650, and his projected monthly mortgage for a new home is $1,068. So the bank determines whether a person qualifies for a home loan based on a metric. At National Road Bank, Ryan's debt to income ratio must be 0.36 or less to qualify for a loan. And at New Savings Bank, his mortgage to income ratio must be 0.8 or less. So let's see if he qualifies. So his monthly expenses are, that's not my pencil, $1,165. And his monthly income is $3,650. So you divide those things, this is what you get. His ratio is less than 0.36, so he does qualify for a loan. Good for Ryan. Hope he gets the house he wants. So let's see if Ryan qualifies for a home loan at New Savings Bank. This is a different bank. So we take the same numbers, right? 1165? No, this time it's 1068. Oh, now we're looking at monthly mortgage right here. So now we're looking at the monthly mortgage over monthly income. So now it's 1068 over 3650. This bank uses a different metric. They're using two different numbers to come up with a different metric. So he gets 0.29 because the ratio is bigger than 0.28, which is what they need to qualify. He does not get a loan at this bank. Oh well. Compare the results of the two metrics. How effective are each of the metrics as measures of whether Ryan can afford to buy a house? Well, one of the banks will give him a loan, but the other would not. So clearly the two banks, they value different things, right? They believe different things, and so they use different values to calculate that. One bank thinks that the monthly mortgage is more important to calculate. The other one, monthly expenses, how much you spend each month. The other one is how much the mortgage would be. So another bank might even want to add those numbers together. You know, if you add 1165 and 1068, that would be the total expenses, right? You divide that by the monthly income, there wouldn't be that much money left. Maybe that would be the best way. All right. Now let's take a look at accuracy. Suppose you measure the width of a laptop screen and record the measurement in meters, centimeters, and millimeters. So the width of a laptop screen would be from here to here, right? That's the width. But I'm sure most of you know this. This is not actually how they measure laptops. Laptop measurements are a diagonal measurement from here to here. So if you have, like, for example, a 13-inch MacBook Pro, then that 13-inch measurement is from here to here. And let's talk about that for a second. 13 inches. Do you think that if you got a ruler and you measured the width of your screen, it would be exactly 13 inches? Or do you think they've rounded up or down? Do you think that it's actually like 12.7 inches or 12.7325, so on and so forth, whatever the actual real measurement is, and then they've just rounded up to get this? How accurate is that? All right, let's take a look at their examples. Determine which measurement is rounded to the nearest whole number. Out of these numbers, which one do you think is rounded to the nearest whole number? Probably millimeters, because this is the smallest measurement. And when you're measuring something like a laptop screen in millimeters, you probably wouldn't need to go down to the decimal points. Which one is rounded to the nearest half? Well, we're probably not measuring meters in half meters when we're looking at something as small as a laptop. We're probably looking at centimeters, right? We'd probably look at like 16.5 centimeters. The nearest tenth. The nearest tenth is probably meters, right? 1.1 meters. That would be a humongous laptop screen. 0.2 meters. I mean, if I were measuring a laptop screen in meters, I might even want to go to hundredths. 0.21, for example. Determine which measurement is the most appropriate for measuring the screen. I would say probably centimeters, and I only say that because I know laptops are measured in inches, and centimeters and inches are the closest measurements. I think millimeters would be a little bit, it would be like too fine a measurement. It would be too accurate. It doesn't really matter. Like when we look at cell phones are like 6.2 inches, 6.5 inches. Like, would we really need to know that it's, exactly 451 millimeters or some other exact millimeter number? Probably not. Which unit of measure is the most accurate? The most accurate is always going to be the smallest one. So that's going to be millimeters. Dante's mother brings him a dozen cookies. So nice. For those of you who don't know, a dozen is an English word for 12. But before she leaves, she eats one. Well, at least she only ate one. And tells Dante that he has to share with his two sisters. So there's 3 people. Dante uses a calculator to divide 11 by 3. And he gets this number, 3.6 repeating. Where should Dante round? Well, there's 3 people. That's not what I wanted to underline. There's 3 people. And there's 2 cookies left over after you divide all the other cookies up, because there's only 11 left. So each person gets the 3, and then there's 2 cookies left. Well, these last 2 cookies, you could divide them into a fraction, 2/3 of a cookie. That would be the most accurate way to go. Of course, how are you going to actually measure 2/3 of a cookie? Ava measures the dimensions of a box at 8.7, 9.52, and 3.16 inches. She multiplies these 3 numbers to find the volume of this box. The results shown on her calculator say 261.72384. Where should Ava round? Well, this is a significant figure question. I don't know if you've learned this before, but you have these 3 numbers, 8.7, 9.52, and 3.16. You have the number with the least accuracy is 8.7. So it is measured to the tenths, which means that when you multiply these numbers, even though you get all these numbers past the 10th position here, these numbers are not accurate because you did not measure this one to the hundredths or thousandths or beyond. And so because you have this one number here that is already at the tenths, then this is what your answer should be in. They don't really explain this in the book, but that's just how it goes. This is called significant figures. I don't know if Ms. Broadhead taught this last year in science. I know I did not, but this is a concept that is important in both science and math. So that's it. Enjoy your day or night.